Hello, this is the third part of the chapter 6.4, and we will talk about Gram-Schmidt process in higher dimensional space. For example, let's just look at the R3. So we have a subspace here which is spanned by the vectors x1, x2, and x3. And our goal here is to create a orthogonal basis for the same subspace. And of course, we will use our Gram-Schmidt procedure when we take our first vector x1, proclaim it the first orthogonal vector v1. Then we take our second vector and project it into the first one to create an orthogonal vector v1. Then we span the space, subspace from vectors v1 and v2 and find an orthogonal projection, call it v3. Okay, but it's a general procedure. Let's just look at the detail. Let's start from our simple favorite space. We take our vector x1 and proclaim it to be a first orthogonal basis vector v1. So basically what we're doing here, we are created a one-dimensional space w1, which is spanned by the vector x1, or since we just changed the notation, it is also spanned by the vector v1. So now our step 2, we will take the vector x2 and we project it on our subspace w1, or the line spanned by the vector v1. And by the definition of projection, we will have the orthogonal vector, which is a difference between our vector x2 and projection x2 on the space w1. And we will use our favorite projection formula. So we will substitute the values for our vector x1 and x2, calculate the dot product, and as a result, get this vector, which is okay, but not exactly the prettiest one. So it will be much easier to work with the more with the whole numbers. So I propose here to use step 2.2a when we are multiply our vector v2 by 4 and get much simpler looking vector. So it will be easier to us to calculate step 3. Okay, so now let's go to step 3. So we are now take the vectors v1 and v2, and we will span the subspace through it, and we'll call it the w2. So, and again, it's a two-dimensional subspace, so it's a plane which contains vectors v1 and v2. So, and to find our orthogonal vector, we first need to find projector of our third basis vector x3 into the subspace of plane w2. And it will contain through two parts. First will be projection of our vector x3 onto vector v1, and the second will be projection of x3 into our vector v2 of v2 prime. And again, we covered this material in the previous section. If you feel uncomfortable, please go and look through the chapter again. Okay, so we will substitute the value for our vectors x1 and x2 and x3, and we will get the value for vector for our projection. So finally, we will calculate our third orthogonal vector v3, which is just the difference between the vector x3 and its projection on the plane w2, plane formed to other vectors v1 and v2. And that will give us the, so this is our first vector x3, and we subtract from this the projection which we calculate into the previous step. And it's give us the third orthogonal vectors. So now we can report our orthogonal basis v1, v2, v3, or provide the number for this orthogonal basis. Okay, now I would like you to go to the end of the chapter and try to practice calculating the orthogonal basis for one and several different spaces.